Dear students, welcome back to my YouTube channel. And we were discussing about the topic molecular rearrangement and transformation. Today, I would like to discuss with you Photoprice rearrangement. Photoprice rearrangement is named after Carrie Theophilus Photoprice and is an intramolecular migration from oxygen to the carbon atom. So we have learned many rearrangement where the migration occurs to the electron deficient oxygen atom or electron deficient carbon atom. And in the case of Photoprice, it's an intramolecular migration take place from the oxygen to the carbon. And Photoprice rearrangement, it is a conversion of phenolic ester into hydroxyl aryl ketone in the presence of Lewis acid. For example, this is phenolic ester. In the presence of Lewis acid, it forms ortho or para-acetyl phenol. And the ortho-para ratio depends on the reaction condition, that is temperature and solvent. And R can be aliphatic compound or aromatic compound. Usually, ortho product, that is this product, orthoacylated phenol, is favored at high temperature and non-polar solvent. And para product is favored at low temperature and polar solvent. Coming to the mechanism of the reaction, and we are starting with our study material, that's phenolic ester, and this oxygen is electron rich, and this can form a complex with Lewis acid, and it form a complex like this, and this lone oxygen get positive charge because this complexing, this lone pair is complexing with aluminum, that is Lewis acid, it accepts electron, so this get a negative charge. And next what happens is a CO bond, this bond, the OCO bond undergo fragmentation like this, and it forms acylium ion like that, RCO, triple bond O, and O get positive charge, and this O minus, it complex with aluminum and form aluminum phenolate. And then this aluminum phenolate and acylium ion is formed in first step, and it can undergo electrophilic aromatic substitution reaction. Now let us see how. So acylium is an electrophile, good electrophile, and this aluminum complex, phenolic aluminum complex, and it can this carbon can act as a nucleophile, and this or paracarbon also can act as a nucleophile, because this phenoxy compound is orthopara directing compound. So this ortho compound, it attack this carbon, electrophilic carbon, and triple bond break, and it form a structure like this. Then it immediately aromatizes to give the product that is orthoacylated phenol. Usually this reaction occurs at high temperature because there is a chance of steric hindrance here. So you need a very high temperature to react this ortho product. But normally at room temperature, what product you get is para-acylated phenox compound, phenol. And the reaction mechanism is like this, and here you can see that it undergoing reaction like this. The electron pair transfer towards here and double bond break, and this para compound react with electrophilic carbon, and it form a structure like this. Then it undergo aromatization immediately, and it form the product para-acylated phenol. Usually it take place, this product you get at room temperature. And you can say this product is one is thermodynamically controlled and another one is kinetically controlled. Kinetically controlled means you get the product faster. Thermodynamically controlled means you need heating. It may take some time to react, and the product will be forming after some time. But at the same time, this will be highly stable one. And in this product, ortho and para, the kinetic product is para product. This one is kinetic and it immediately formed. There is no steric entrance and this para position is more active and this easily formed. And the thermodynamically controlled product is the ortho one, and it is very difficult to form sometimes because of its steric hindrance, and you need heating. Heat is required to make it formed, the ortho product. But at the same time, once the ortho product is formed, you can see that it can form a stable bidentate complex like this with aluminium. So that means once it is formed, it is highly stable. That means it's thermodynamically controlled product, and the para is a kinetically controlled product. Example for Price rearrangement, and this is the one example. You can see that this is the acylated part. You see, and this part is acylated, and here this is the ortho position, and this para is already one substrate is there. So this acyl group will migrate to the ortho product, ortho position. And second example, you have this compound, and this is acyl group COR, and in the presence of uric acid, and this para position is this one, and this is already occupied, and our ortho is this one. So acyl group will migrate towards this ortho position, and at the same time you get a product having double bond like this without this single bond, and this OH can react with this single bond and it form a cyclic product like you have seen before. Okay, next one is a modification of Price rearrangement. That's Photoprice rearrangement. It is a photochemical variant of Price, and it is also an intramolecular free radical process. It is a free radical process, not like a previous mechanism. Previous mechanism was ionic, and the yields are low and not useful commercially. And this is the mechanism of reaction, and this is this ester, phenyl ester, in the presence of UV light, that is light, it undergo fragmentation and it forms phenoxy radical and acetyl radical. And these phenoxy radicals are resonance stabilized, and you can see that the radical is there in resonance at ortho and para position. You get here. Okay, and these two radicals recombine to give the product, and this is known as Photoprice rearrangement. For example, in this particular case, you can see that this is aromatic acetyl group, and in the presence of UV light, you can see that this acetyl group will migrate towards the ortho position because the para is already occupied, and you can see that product as acetyl group here. And in summary, we have learned an intramolecular Price rearrangement is an intramolecular migration usually taking place from oxygen to the carbon, and it is a conversion of phenolic ester into hydroxyl ketone in the presence of Lewis acid. And ortho-para ratio product depends on the reaction condition, that is temperature and solvent. And Photoprice rearrangement, it is a photochemical variant of Price, And it is an intramolecular free radical process taking place in Photoprice, and usually yields are low in Photoprice and not useful in commercially. And thank you for watching.